Changing a tire actually involves quite a bit of physics. The concept in physics that helps the most in changing a tire is called torque. Now, unlike a linear force that causes an object to move in a straight line, a torque is a kind of a force that causes an object to rotate around an axis. The object we're trying to move when changing a tire is the lug nut. Now, we're not interested in making the lug nut go in and out, side to side, up and down in a straight line. We're trying to get the lug nut to rotate on an axis or around an axis. Well, in comes torque. If I were to pinch this lug nut as hard as I could and try to rotate it, I am simply not able to produce enough torque in order to make that nut move. So, the manufacturer includes a tire iron. Now, the importance of a tire iron is that it moves the force away from the axis of rotation. The axis of rotation on the nut is right along this line. And by putting your hand at the end, you can see that the force being applied is further from the axis of rotation. When it comes to torque, what's more important than how much force you're using is how you use that force and where you use that force.
Okay, here's the demonstration I wanted to show you. Check this out. Now this thing wants to twist just a little bit, but you can see that I'm clearly not holding it up and leveling it in any way, shape, or form. Well, now you can see where some of my numbers came from. Now, we certainly used appropriate distances for my arm in terms of bicep and all that business, and length of arm and masses, but the reason I chose some of the masses was because I had a 2.5 pound weight, a plate mass that I could put on the end here. In addition, my arm being a little less than a pound, I just estimated it being roughly a pound, 4 newtons. Well, that's kind of the mass of my piece of rebar here. So I went with these numbers to illustrate this point. A little bit manufactured, but the point is really cool. What you see here is, and I want you to look at the scale, we mathematically determined that the force of the bicep was producing about 34.4 pounds, which is about 35, and that's exactly halfway between 30 and 40. Well, and you might even notice that the scale I'm using, it's the only one. Could not find a scale, a spring scale that did what I wanted it to do, like this. So I took one of my old garage door springs and made my own. That is what this is. It's a garage door spring. And I put 10 pounds and measured the distance, 20 pounds and measured the distance, 30, 40, 50, and that's where I got my scale from. So you can see that 34 pounds, roughly 35, is right where we predicted it to be. In addition, the plate mass is 2.5 pounds, and what you see right down here, and I'm not going to touch it, but what you see in these 3 plates is a 25-pound plate, a 5-pound plate, and a 1.25 pound plate. And that makes roughly 31.25 pounds, which is very close to our estimate of 30.8 pounds as the reaction of the elbow. So if the elbow is pushing down, well, let's get this in the orientation of our arm here. Okay. Now, the other piece is where you see the tape is just kind of provided for me to put my support pieces between and hold them there. But this piece right here, from this distance to this distance, between this gap, center of this gap to center of this gap, is 3 centimeters. In addition, the center of this gap to the center of the gap that the 2.5 pound weight is on is 35 centimeters. So we have all the appropriate distances and modeled right here for you. So I'm estimating the weight of my bicep to be 35. I predicted it at 35, and you can see that it is 35. And you can see that the elbow's having to push down at this location in order to hold this melon, this 2.5 pound melon at 35 centimeters away from the elbow. Absolutely magnificent. Awesome visual. If you were to unweight these, you're talking about 35 pounds worth of mass, and that's a lot of force. So just holding a melon, you wouldn't think that it takes 35 pounds to hold up a 2.5-pound melon. Well, it's not about how much force, it's about the location of that force and how it's being applied. We approximated it as being vertical for this demonstration. And you can see that when it's really close to the axis, it has to be a great force to produce even a small torque. So an awesome visual right here. The body is awesome.